So also, when you're looking at the book, chapter 19 is really what this is all centered around. Part of the assignment is going to be from these programming challenges. So you may want to actually take a look at these. I will be assigning some of these for the next assignment. Understanding trees is actually a pretty fundamental part of programming because it combines the best aspects of both a list and an array, in that it is easy to find the center point in a tree because the root essentially is the center point in a tree. I talked about rebalancing earlier, and I just want to touch on that. When you are programming trees, oftentimes there will be some sort of rebalancing function. I'm taking a look here and seeing if we have something like that in these. In these C++ files. Note that also for the C++ files here, for the 01 through 10, you're going to need to rename the main method, otherwise it won't compile. So note that in this 909, the key to a tree, to doing your own tree, is overriding the less than and greater than symbols. So note that determining when something is less than something else is a key ingredient. Okay, here we're overriding the output operator. That's operator less than. We're outputting C out. But you are going to want to output the less than and greater than operators if you have something more involved than a single string or a value. So for our student class, if this student less than another student means something different than just say 3 is less than 5, then we're going to need to override the less than operator. Much like we have here, we're overriding this operator, so we're essentially going to override the less than operator. There are other examples of this in the book. Here's one here. So here we have an employee. Here we're overriding the less than operator, and the Boolean is what's returned from the less than operator. We have two employees. Employee X is actually on the left side. Employee Y is on the other side. So when we write this, we are writing X less than Y for these employees. We are writing X less than Y for these employees. And what is happening is we are taking this employee X, we are looking at this ID, and we are determining whether that ID is less than the Y ID. Again, like as with students and faculty and persons with the last name, right? We would determine, is the last name greater than, less than, or equal to the other last name, and then we would actually take the first name at that point. Okay. Here again, we override the equals operator. We override, where is it? The greater than? Or is it just the less than? Oh, we're overriding just the less than and the equals operator. But these are the operators we need to override to ensure that our newly created classes are compatible with trees, because in creating trees, we need to determine whether something is less than, greater than, or equal to another value. And if it's not something basic like a double or an int or whatever, then we need to determine what that means. So we need to override those operators to determine, oh, what is the meaning of less than? What is the meaning of greater than? And we can say, well, the meaning of less than is if the last name is less than the other last name, or if they're equal, if the first name is less than the other first name, or if those are equal, if the middle name is less than the other middle name, etc., etc. All right. So you get the idea of why we would do that, but note that we are doing that in these cases, and you want to follow this type of logic. Note we have employee objects, so we would be passing in something other than employee objects, but then this return value would be something totally different for, say, your students. All right. When we're talking about B trees, there is a large number of methods that we actually do need to incorporate into our classes. These include things like, well, we're not going to go over width necessarily. Height is one that you might want to do, right? And height might be if you might want to determine the height of the left and the right as to whether you need to rebalance the tree. Here, search, insert in order. Okay. And then operator equals is whether a tree is equal to another tree, or whether a tree is equal to a copy of itself. And you can take a look at what additional functions are relevant for your particular application of this tree. We'll be assigning homework from chapter 19. I'll just need to determine what is valuable in there. But keep in mind that we'll probably, if we're doing it trees, we're probably going to be doing trees of students and faculty, much like we had in the last assignment that was handed out today. So we'll be working with those same objects. So again, determining what less than means or greater than means to a specific student or a specific faculty is going to be imperative.